You know, it's funny. Some of the most interesting and honestly ambitious designs are hiding in plain sight, sometimes in the very last place you'd ever think to look, like a government-issued textbook.
Okay, so let's just dive right into this with a little bit of a puzzle. And this one's found inside a series of official high school textbooks from Lebanon, first published right around the year 2000. So you open up the 12th grade chemistry book, you flip to the chapter on reaction rates, and boom, you're greeted with this photo. A really dramatic shot of a fire breather. It's an interesting choice for sure, maybe a little unusual. Okay, then a few pages later, you get this. A full-page photo of a building being demolished with explosives. And remember, we are still inside a high school chemistry textbook. Then you switch gears, you pick up the algebra textbook. And here, in a breakdown of a section, you find these cartoon dice and this bright, explosive BAM graphic. I mean, what is going on here? These images feel completely out of place, almost random for advanced academic stuff. It honestly feels more like a comic book than a calculus primer. So what's the story behind this really unique design? Well, the answer starts with where these books even came from. See, they weren't just another print run. They were part of this massive, nationwide educational initiative, a really key piece of a country trying to rebuild itself.
So, back in 2000, Lebanon's Educational Center for Research and Development, or ECRD, rolled out what they called the National Textbook Project. Now, this was a decade after the end of a long civil war, so this was a huge deal. It was a major initiative to create official, unified books for students all across the country, with the big goal of fostering a whole new generation of thinkers.
The president of the center at the time, Nirmer Freha, wrote this right in the foreword. He really emphasized using up-to-date methodology to encourage individual thinking and research. So you see, this project had a very clear and very ambitious mission.
And that's the crucial point. This wasn't just about updating some facts and figures. No. This was about putting a whole new philosophy of teaching into practice, which the authors themselves laid out right there in the book's preface. The authors just state it plainly. This book is not a collection of facts you're supposed to memorize. It's a tool designed for active learning. And they built this tool to serve a very specific division of labor within the whole educational system. And here's that division of labor. Just notice the shift in power here. The student is no longer some passive recipient. They're an independent learner. The instructor isn't just a lecturer. They're a guide who promotes research. And the administrator's job? To make all of this possible. The textbook was the tool specifically designed to serve this pretty radical new structure. Okay. Now here's where it gets really, really interesting. This philosophy, it wasn't just some nice-sounding talk. It was a systematic, almost rigid formula that they applied to every single chapter, across every single subject. Let's hop over to the math books and you'll see what I mean. On the left, that's the start of Chapter 1, on logic. On the right, Chapter 12, on groups. Just look at the layout. It's identical. Introduction, a box for prerequisites, and then a section for activities. This was absolutely not a coincidence. It was the system. And this structure, it reveals their entire method. Every single chapter follows this exact path. You start with prerequisites. Then, and this is the most radical part, you tackle activities. These are problems you're meant to wrestle with before you're even taught the material. The whole goal is to spark curiosity, not just give you answers. Only after that do you get the actual lesson, followed by summaries, practice, and that mysterious just for fun section. What's wild is that this rigid structure actually created flexibility. It allowed them to present these deeply theoretical concepts, like Euler's formula, on one page, and then guide students through hands-on practical lab investigations on another, all inside this consistent, predictable framework. And this brings us back to those quirky graphics and the most unusual and maybe the most controversial feature of these textbooks, that just for fun section at the end of every chapter. You know, the authors, they knew this would raise some eyebrows. They totally saw it coming, that critics would call it a waste of time. But they defended it, arguing that the benefits of independent research and group work were absolutely worth it. So what did they consider fun? Well, how about this little problem from the end of the chapter on group theory? Determine the group of isometries of a square. Now look, that might not be your idea of a good time, or mine for that matter, but it perfectly aligns with their whole philosophy. The goal wasn't just to entertain, it was to push the curious students beyond the core curriculum and get them engaged in what is basically genuine mathematical research. So, what's the big takeaway from all this? The fire breathers, the super rigid structure, the impossibly hard fun problems? I mean, what was the ultimate point of it all? Well, the answer was right there all along in that same foreword from the president of the ECRD. The entire design, the weird pictures, the structure, all of it was built on a single really powerful idea. A textbook shouldn't be the final word. It has to be a starting point, a stepping stone to genuine discovery. This really ambitious Lebanese project, now more than 20 years old, was so much more than just a textbook redesign. It was a radical experiment in learning. And it leaves us with a critical question for education today. Are we designing tools that merely deliver information, or are we creating catalysts that can ignite true, independent curiosity? The answer to that, well, it might just be hidden in the last place we'd ever think to look.